All right, so this is for tonight. So we are talking about looking at a graph, right? So you know now how to look at a table and determine if it's proportional or not. And then today it's just taking those values from the table, put them on the graph, and see how what a proportional graph looks like. So one of the things that you got to look for if it's proportional, two things are going to happen. A, it's going to be a straight line that goes through all these points and also goes through the origin. That's a must. It must go through the origin. Okay? And it's a straight line. So visually, you can check really fast if a graph is proportional that way. Now, the long way of checking that, just to be extra careful, is to get a few points from the line. So let me create a table of values here. Now I select a couple of points, and they selected a couple for us: 2, 5, 0.410. All right, select points that you can actually determine the value. 2, 5, let me see, 410. Is there any other point that I can actually precisely tell you the value? And here, this is actually 1, and 1 goes with 2. No, 1 goes with, actually we can't really tell, so I'm not going to do the 1, but we can find the unit rate. So given that these 2 points I can precisely tell where they are, I'm going to use those 2 points to create my table. Well, let's find the constant proportionality. So to find the constant proportionality, right, remember, the y value over the x value, right? So it would be times 2.5 times 2.5. 2 times 2.5 is 5. 4 times 2.5 is 10, right? So same constant proportionality for whatever order pair I use. So that tells me it's proportional. 0, 0, right? 0 times 2.5 is 0. And then I'm going to put a 1 here. And when x is 1, we can't tell by the graph, right? Because we can't precisely tell what that is. But if we do it on the table, 1 times 2.5 is 2.5. So 1 here, and let's see if I can go. That looks like this. They're telling us that this is 1, 2.5. Right? It's kind of hard to see on the table, but from the graph, but on the table I can see it. So here, there's my unit rate. Let me label things. This is my unit rate. 2.5 is my constant proportionality. So let me write the unit rate. There is no. I'm gonna make this up. Apples. I'm making this up. Cost. Actually, let me change that. Gallons and miles that I drive. That makes it easier. So it's saying that the unit rate is for every gallon that I have in my car, I can drive 2.5 miles. It's a really old car. I drive 2.5 miles. And there's my unit rate. Right? It's right here. So I didn't have the unit rate to begin. Well, I had it in the graph, but I couldn't really tell what that value was. So I used the table to actually find the unit rate. What's my equation? Well, if I do it in terms of y and x, y, the number of miles I can drive. So if I wanted to find out how many miles I can drive, I need to know how many gallons I have in my car. So it's 2.5 times x. Let me just write this. This is the total number of miles I can drive. This is the total number of gallons that I have in my car. And what does a 2.5 represent? Yes, this is a constant proportionality. It's a unit rate, but in the context of the one I just invented here, it's 2.5 is the number of miles, 2.5 miles per gallon. That's what the 2.5 stands for. Okay, so this one I went backwards, but I want to show you that these points can go back and forth, right? You can put table values or you can represent in the graph. So what's the characteristic in the graph of a proportional table? Well, if it's a proportional relationship. So if the table was proportional and you transferred those ordered pairs into a graph, you will notice that every proportional table we'll have a, if you connect the points, and remember what I talked about in class, you can connect the points depending on the context of the story. In this case, it makes sense. Your line's going to be a straight line, and it's going to go through the origin. So that's visually a check that you can do. Okay, and then, but if that's not enough, again, you can take a few points from this line, put it on the table, find the constant proportionality, make sure it's the same for every ordered pair, which it is times 2.5 times 2.5 times 2.5, and you can prove that it's a proportional graph. But on a graph, right, if all they gave you a graph and they ask you, is it proportional? Is it a straight line? Does it go through the origin? If those two are yes and yes, you have a proportional relationship. That's it. Okay, it can't get any simpler than that. So let's go through some of the problems. So question 1, they don't give us a context. They don't give us a story or something to work with. Right, so they're just asking, hey, are these 3 points represent a proportional relationship? Well, I don't know what the context is, but I'm going to connect the lines, right? If I were to get a ruler and connect these, would this be proportional? Well, would that show me a proportional relationship? Well, yes, and the answer is yes. Why? Straight line, and it goes through the origin, right? The points, this line passes through the origins if I were to connect it. Now, I'm not going to do this for every question, but for this one, just in case, clear page, just in case that was not enough, you're not happy with that information. Well, let's see, let's get this point here. This point is 10, 8. This point here is 5, 4, right? Let me use those 2 points. This point I don't want to use because I really don't know what the value is. That looks like 2.5 and 2. I'm not going to guess, so I use the points that I actually know the coordinates. So let me put this on the table. Let's prove it that way. So let's take 5 and 4. Remember, this is the x coordinate, this is the y, so on 10 and 8. Okay. What's the constant proportionality? Well, to find the constant proportionality, right, I'm going to divide the y value over the x, and if I divide that, I'm going to get 4 over 5. 4 over 5, if you change to a decimal, 0.8. So take a calculator, and let's just go ahead. Right, so this says times 4 over 5, or 0.8, times 4 over 5, times 4 over 5. So if you multiply 5 times 0.8 or 4.5, do we get 4? We do. What if I take 10 and multiply by 4 over 5 or 0.8, do we get 8? Yes, we do. So these 3 points, and although I don't know that one, you can tell from the table, it's the same constant proportionality, so they represent a proportional relationship. And then just visually, if you had a ruler and you were to connect, look, it's a straight line, right? And it's proportional. Okay. This one, is it proportional or not? Again, we can do it 2 ways. Pretty sure you don't want to do it 2 ways, but let's do it visually. If I were to connect these, would these 3 points make a straight line, and would it go through the origin? The answer is yes and yes for both. Make this proportional. Okay, and again, if somebody asked you, right, take the points from this relationship, whatever this is referring to. Let's take this one. This is 0.5, 1. Because there's a 1 over here. This one is 10, 2. You can put it on the table. 5, 1, 10, 2, 0, 0, because we have that point. Find the constant proportionality, right? Is it the same? Well, I'll actually do it. The constant proportionality is times 1 over 5, times 1 over 5, or 0.2, however you want it. Does it work? Yes, it does. So is it the same constant proportionality for each pair between the 5 and the 1 and 10 and 2? Yes, it is. So from a table's perspective, it is. From a graph perspective, it is, because I can connect these. It goes through 0, 0, and is a straight line. Okay. That's it. I mean, I think they want this visually. So visually speaking, let's connect these. If I were to connect these, look, does that look like a straight line? It's not. Okay, so is this proportional? No, it's not. Does it go through 0, 0? It does, but it's not a straight line, so not proportional. The rate of change is not the same, not proportional. This one, again, visually speaking, connect. The straight line, check, yes. But what is it missing? Oh, it does not go to 0, 0, the y-intercept. Right, sorry, we'll talk about that later. But at 0, where is the y value? So if you were to create a table, x and y, you would have this point, which is 0, 6. This point is 5 and 7. And this point is 10 and 8. You can already tell that there's no way it's going to be the same constant proportionality for each order pair. First of all, 0, 6 in the proportional table, when you have proportional relationship, when you have 0 for x, what should be y? Y should also be 0. Okay, so this is definitely not proportional. Okay, so it's just a different view, right? So you were working from the view, from the perspective of the table, and now it's from the perspective of a graph. Select all representations that show a proportional relationship. This is definitely a no, not proportional. Right? It's a straight line, but does it go through 0? No, it doesn't. This one, yeah, looks like it, right? So look, definitely goes through 0, 0. Straight line, yeah. And then again, if you're not satisfied, you can select some points. So if you were to make a table, I would select that point because I know its value. I would select this point because I know its value. I can select this point because I know its value. You can create a table, XY table. So this one would be 2, 1. So 2, 1. This one would be 4, 2. And this one would be 6, 3. What? Right? So what's the constant proportionality? How does X become Y? Well, it would be times a half, times a half, times a half. Right? Where's your unit rate? Well, you can create one here. 1 times a half would be 0.5 or a half. Right? And because we don't have a context, I'll just leave it at that. So is it the same constant proportionality for each order pair? Yes, it is. Straight line? Yes. Goes to the 0, 0? Yes. This one is definitely a check. This one, well, look here. Right? So 2 times what is 3? Well, it's times 1.5. Right? Does that make sense? 4 times, is it times 1.5? Because if it's times 1.5, 1.5 we're good. It's 6 times 1.5, 27. So this is a yes. This it's a no because it's a different constant proportionality, right? And this is a no. So this would not be. So we can just write not proportional. Although look, it has 0, 0. It fails on the other condition where the same constant proportionality should be for each order pair. So this one, 0, 0, check. We like that. 2 times 6 is 12. 4 times 6 is 24. 6 times 6 is 36. Same constant proportionality for each order pair? Yes. Proportional? Sure. Okay. Arturo earns $33 for babysitting for 4 hours. Okay. At this rate, how much will Arturo earn if he babysits for 7 hours? You got options. You got so many options here. It's not even funny. Option 1, we can create a proportion. So let's say for $33, if I work, to make $33, I have to work 4 hours. There's my ratio. And then on this side, I keep the units the same. On the top, numerators, dollars and dollars, and at the bottom is hours. But they're asking us, what if I work 7 hours? The question is, this guy. This is my question mark, right? So instead of the question mark, I'm going to write X. You can cross multiply. You can find a relationship side to side, up and down, however you want. I'm going to cross multiply. I get 4x. And on the other side, I'm going to multiply 33 times 7. And I get 231. Divide by 4, divide by 4. And I get that I'm going to make X. The amount of money I'm going to take home is going to be $57.07. So you could have done that. Is there a different way? Well, you could create a table. So let's talk about hours here. I work 4 hours, I make money earned. I make $33. Question was, what about 7? Like I said, you could have found what times 4 is 7 and apply it here. Okay, or you can find a constant proportionality. How, right? So we can go 4 times something is 33, and then you're going to apply the same constant proportionality here. To find a constant proportionality, you would have done K. Our constant proportionality is 33 over 4. Let's see if that divides nicely. 33 divided by 4. It does. It's 8.25. So 8.25, you know that this is going to be 825, and then I'm going to add the 1 here, times 8.25. So if I work 1 hour, I make 825. There's my unit rate. Right, so if I work 4 hours times 825, if I work 7 hours times 8.25, and notice that if I multiply that, I get the same answer that I did when I solved the proportion. Okay, unit rate, can you come up with an equation? So to find out how much money I'm going to make, right, y, do it this 2 ways. To find out how much money, instead of money sign, I should have, to find the total amount of money I'm going to take home after babysitting, I'm going to take the constant proportionality, 825, and multiply by the number of hours. If I use the letters to represent the context of the story, the total amount of money, T, is 825 times H, the number of hours. Your choice. 4, okay, so 4, a lemonade recipe calls 1 cup of water for every 1/4 cup of lemon juice for every 1. Here's my unit right here in terms of 1 cup of water, right? Here's my unit rate. So, if you know your unit rate, it makes life super easy because automatically I know the constant proportionality is 1/4 times 1/4 times 1/4 times 1/4. Okay, do I need this right now? Let's see if I even need it. Graph the order pairs to determine whether the relationship between water and lemon juice is proportional. Well, we proved it in the table, right? I found the constant proportionality right here. And then 2 times 1/4, is it a half? Yes, it is. 3 times 1/4, is it 3/4? Yes. 4 times 1/4, is it 1? Yes, it is. So from the table perspective, proportional. So when I graph this, obviously, it should be proportional as well. What about if I have 0 cups of water? Well, I'm going to use 0 cups of lemon juice, right? That makes sense, times 1/4. So let's start. And again, just because a table didn't give you 0, 0, or 5 cups or 6 cups, there's no reason why you can't add it. Okay? So let me start with 0. 0 cups of water, and here's the water. Water is my x-axis, and lemon is my y-axis, so I can do this here on top. 0 cups of water, 0 cups of juice. 1 cup of water, 1/4. So someone's going to say, oh my God, where's 1/4? Well, think about this for a second. If that's 0 and this is 1, that would be a half, right? And half of a half is 1/4. So if I took here, 1/4 should be about here, right? That's 1/4. So shift over, 1/4. 2, half. Half is just a little bit higher. 3 cups of water, it would be 3/4, a little bit higher. 4 cups of water, finally 1 cup of juice. Can you connect? Yeah, we can. Well, then we come to the point of this and ask ourselves, should I connect the dots or not? Well, I guess we can. Well, I guess we can in this in the context of this story, we can because what if I use half a cup of water? Is that a possible scenario here? What if I use 1 1/3 cup of water? Then I need this point, I need this point. What if I use 2 7/8 cup of water, which would be right here? So I would need this much juice. So in this case, I think we can connect the dots because it would make sense. Let me just bring that over here. Come on. Why is this not moving? Why is nothing moving? So draw the straight line again. little better. A little better that way. Go like this, right? Notice that the dots are all on the line. It goes through 0, 0. If I were to stretch a line, it would go 0, 0. Do I need to stretch a line this way? No, because can we have negative cups of water? We can't. So it doesn't make sense for me to stretch it to the other side. Proportional. Okay. And is that it? There's more. Spiral. Oh my god. A turtle is walking away from a rock. Okay. X represents time. So here, let's make an X column. This is the time. Let's call it time. And in minutes, okay, time in minutes. So let me write minutes. And Y represents a distance. And Y represents a distance. If X and Y are proportional, so it's a proportional relationship, meaning the turtle is walking, right, at the same pace. Okay, so if the turtle doesn't walk, okay, so here's the rock, and here's the turtle, right, on top of each other. So at 0 minutes, where how far is he from the rock? He is 0 inches, or what is it? What is the distance? 0 meters away from the rock. So as he after 1 minute, right? So if you look at the first one, after it says y equals 3x, which means that remember, think about what that means. Y means the distance, right? 3 is the constant proportionality, or we'll get that in a second. X is the minutes. So in the context of this scenario, what does a 3 represent? 3 represents 3 meters per minute. Right? So after 1 minute, he is 3 meters away from the rock. After 2 minutes, it'd be 6. After 3 minutes, he's 9 meters away from the rock. So thinking about this, I created a table, multiply all the x values by 3, and that's exactly what I'm doing. Times 3, times 3, times 3, and so forth, and so forth. Right? So I took that, put it in a table. Could this represent the equation y equals 3x? Could it represent the distance that the turtle walks? Yeah, definitely. So this one, yes. And remember what a proportional equation looks like. It's always going to come in this format. No plus, no minus anything, right? So y equals kx, and that equation represents the equation of a proportional relationship, so that's good. The turtle walks for a bit, then stops. Okay, right there, it's enough. If it's proportional, it's the same pace, not stopping. It's just walking and walking and not stopping. Right? Because once you stop, everything changes. Right? The turtle walks away from the rock at a constant rate, and that's exactly what I just said. Same pace. So this one is good. The equation y equals x plus 3 could represent the distance that the turtle walks away. No, there's a plus 3 here. How is that possible? Look, this is the time, minutes, and this is the distance. How do we explain that at 0 minutes he's already 3 meters from the rock? I don't know. Maybe before the time even, so whoever's timing this, he said, you know what? I'm going to put you, turtle, over here, and now I'm going to start the clock. So at 0 seconds, 0 minutes, where is the turtle? At 3. Is this going to give us a proportional relationship? No, it's not. So, you know, the table has to be 0, 0, and this equation, if the 3 wasn't there, then we would be okay. But there is a 3 there. So that should make it proportional. After 6 minutes, the turtle walks 18 meters, and after 10 minutes, the turtle walks 20 meters. Well, is that a proportional relationship? Well, let's create a table. And let's look at those two ordered pairs. So at 6 minutes, he walks 18, and after 10 minutes, he walks 20 meters. Well, is the constant proportionality the same? 6 times what? It's 18, it's times 3. It's 10 times 3, 20? No, it's not. It fails here. So was he walking at the same pace? No, because at 3 meters per minute, right, after 10 minutes, this should have been 30. So he slowed down, right? So this is no as well. and this was a no too. Okay, so a little bit of understanding, right? So you know what a proportional table looks like. You know what a proportional equation should look like. It should always be in this form: y equals 2x, y equals I don't know, 1/3 of x, y equals 0.8x, y equals 25.5x, y equals 100x. These are all representing proportional relationships. Once you start plus 2, minus 5, plus 80, plus 20, that's already not a relationship, not a proportional relationship. Think about the problem we did in class, the bank account, and the other bank account where grandma helped out a little bit, which was the plus 20, right? So proportional, not proportional. Okay, that's literally it. Wait, there was the additional. So let me make a video on the additional. I gotta download it first. Un segundo. Additional. So, my battery dies. Balance. Additional. No. Move. Share. Please. All right. So I know. Little pause. Let me get the additional. Here we go. So this was the additional. Okay. And let's talk about this. Select all the something statements of the graph of proportional relationship. So let me draw a graph here. Here's my x and y coordinates. Here's my x and the y. In order to be proportional, we know two things. It has to go through 0, 0. Actually, you know what? I'm going to draw a line like this. It has to go through the origin, right? And it has to be a straight line. The points in the graph form a curve. No. Points in the graph form a straight line. Yes. Check. The graph goes through the origin. Yes. The graph must be a solid line. So this is what they mean by that. Can it be like that? Or let me draw another graph somewhere over here. Let me draw a small graph. Or could it be this? Right? Remember some scenarios. It doesn't make sense connecting the dots because the values between those points don't make sense in the context of that story. So would this be a proportional relationship? Yeah, look, if I were to connect this, it would form a straight line. Does it go through 0, 0? Yeah, so must be a solid line? No, that's not true. Sometimes it is, sometimes it isn't. The graph could be a series of points. Oh, definitely. Look at that. I just did that. I didn't even read it. That's that. Let's see. Problems 2. Determine if the graph or table represents proportional relations. So visually, let's do this visually because it's, let's save some time. So this one, the first one. Not that one. This one. If I were to connect. Straight line, yes. Do you see it going through the origin? Here's the origin. Right? Here's the origin here. Is it going through that? So does it represent a proportional relationship? No, it does not go through the origin. This one. Oh, look at that. I connected the dots only to show you, right? If you were to, I don't know what the context is, so just to show you that it's a straight line and that it goes through 0, 0. So this is a yes, or it's a proportional relationship. Oh, and if that was not good enough, you could have gotten some points and created a table. So I'll do that. You probably want to do this visually, but if you were to ask for a proof, well, this is 2, y is 1, right? This is 4, y is 2, and there's a 5, 6, 7, 8, y is 4. Look. Do you think, does that look like a proportional table? Yes. Times a half, times a half, times a half. Same constant proportionality for each pair, for each order pair. So if you were to pick this pair, etc., still be same constant proportionality? Yes. So you can prove it visually on the graph, and even if they wanted something extra, you could have put those points on the table and found the same constant proportionality for each order pair. Is that it? Okay. 4. Blah, blah, blah. We already know visually, clear page. We already know visually, not proportional. Not proportional. Not proportional because, I don't even know what the question was, because it does not go through the origin. Okay, and there. Think about the bank account, or again, whatever problem it is, the same problem, but with a different context, right? At 0, 0, if I were to create a table for this, look, at x is 0, y is already 20. At x is 10, y is 30. At x, and let me just pick another one, x is 20, y is 40, and then I'm going to pick one more, this one, x is 30, y is 50. Can you see that there is no same constant proportionality for each order pair? So let me just pick here. 10 times 3. So this should have been times 3. This should have been times 3. So this is a yes, but it fails. Fails here because it's not times 3, and this is not times 3. So from the table, you can see that's not proportional, and then from the graph as well, you can see that's not proportional. So it's not because it doesn't go through the origin, right? At 0, it should be 0. At 0 miles, it should be $0 to rent the moving truck, right? How can we explain this? How can I explain that? Well, if I drove 0 miles, I rented a truck, and I haven't driven it yet, and I already paid 20. Maybe they charged me $20 for, I don't know, to actually get the truck, and then there's a cost per mile. Okay, so $20 just to get the truck. I haven't even driven it. They charge me $20. And then if I want to drive the truck, I gotta pay. There's a cost to pay per mile. Every mile that I drive, it's a certain cost. Okay? Yeah, they charge you for everything. 5. Complete the table. Okay, seriously? This one. So again, if you don't like the table looking that way, you can put it this way. Up to you, 0, 2, 4, 6, and the only one that we know, we have to base everything, is this one, 12. Constant proportionality, 12 over 4. The ratio between y and x is 3, so times 3, times 3, 6, times 3 is 0, times 3 is 18. So now if you take any order pair, let's take 18 and 6. Look, it's 3. What if I took 6 and 2? It's 3. So notice, right, that this is a proportional table. So what was this? 0, this was 6, and this was 18. Fiona earned $50 for mowing 4 lawns. So again, it's here are lawns. Here's the money that she made, and this is all we know. What happens when you mow 6 lawns? How much can you find the constant proportionality here? Right, so to find the constant proportionality, you would do 50 over 4, right? And you would get 12.5. You know that this is 12.5. It would be 12.5. And I'm going to add 1. I know they didn't ask for it. Times 12.5. So 1 lawn, I get $12.50. 6 lawns, I get $75. And that's the answer to the question. Right, so I'm just going to take one step over. What if you didn't want to do that? That's too much work. Well, I'll set up a proportion. 50, I have to mow 4 lawns. Right? Equivalent ratios, right? 50 over 4. What if I mow 6 lawns? How much money, right? You can cross multiply. You can find that, hey, from 4 to 50 is times 12 and a half. So from 6 to the total cost that I want to have, it's times 12.5. Can you cross multiply? If you cross multiply, you get 4x equals 300. divide by 4, divide by 4, and x equals 75 bucks. So many ways you can do this. Okay. And the last one. Bathtub is being filled at a rate of 1/3 of a gallon per minute. So there's our unit rate right there, per minute. So here, my unit rate. If I have my unit rate, life is so much easier because automatically I know my constant proportionality. It's the same number times 1 and 1/3. I'm going to write times 1 and 1/3 times 1 and 1/3 times 1 and 1/3. So I want to graph this. Oh, why did they pick? Oh, man. So think about it, and then let's add 0 minutes. If there's 0 minutes past, how much water is in this bathtub? Obviously, 0 gallons. So we're going to start with that. And remember, nothing tells you can't add 0, 0. This is my x value, and water gallons, they told us that's our y value. So 1 gallon. And again, you're going to have to eyeball this again. 1 minute past, you get 1 and 1/3, which is about here. 2 gallons is 2 and 2/3, which is about here. 3 gallons is 4, which is about here. And 5 gallons, 5 and 1/3, which is about here. Now, this one I'm going to connect the dots because I'll show you in a second. If I connect these, notice that they form a straight line. It goes through the origin. So let me go to the points that I had before. So you had this point, you had this point, you had this point, and you had this point. Now, does this point here that I put in orange make sense to you? Let me pick this one right here. Right here. Well, it looks like 1.5. So if I want to say, hey, after a minute and a half, how much water do I have? Can you figure out? It looks like 2. Right? So it looks like 2. I'm actually going to do it. So after a minute and a half, so if you had 1.5, you're going to multiply that times that 1 and 1/3. Let's see, 1.5 times 1 and 1/3, we would get 2. Oh, so the graph was correct, so we get 2. Does that make sense in the context story? Can I go 1.5 minutes? Can I go 3 minutes and 10 seconds? Can I go 4 minutes and 45 seconds? I can. So all these points, every single point in this graph, and there's billions and billions of points in this graph, do they all make sense? Is it possible to actually see those points in real life? Can I time it at 1 minute and 5 seconds to see how much water do I have in my bathtub? Yes, I can. So in this case, I would connect the dots. Okay. Is that it? Yeah, that's it. Super simple, no?